All right, let's talk about Java. If you've ever designed a class, you've probably run into this classic problem. Either you let anyone extend your class, or you lock it down so no one can. But what about the middle ground? Well, today we're diving into Java's really smart solution for this, sealed classes.
For the longest time in Java, it was one of two extremes. You either had this total open door policy, right? Any class could come along and extend your base class, which could sometimes lead to some really messy and unpredictable code. Or you had the opposite, a complete lockdown using final, which just slammed the door on any extension whatsoever. This all or nothing thing, it left a pretty big gap in how we could design our application.
So here's what we're going to cover. We'll start with that classic inheritance dilemma. Then we'll introduce our new tool, sealed classes, and I'll break down the 3 super important rules that their children have to follow. We're going to see it all in action with a code example, check out how this also works for interfaces, and then wrap up with why this feature is such a game changer for your code.
Okay, so first things first, let's really set the stage and look at the core problem that sealed classes were built to solve.
This slide really nails the old choice we had to make. On one hand, you've got abstract classes. You're basically saying, hey, here's a blueprint, go wild. Anyone can build on this. And on the other hand, final classes, which are like, nope, this is the finished product, don't touch it. We were always missing a way to say, look, here's the blueprint, but only a few specific pre-approved builders are allowed to use it.
And that's exactly where sealed classes come into the picture. They are the perfect solution to that all or nothing problem we just talked about. So what is a sealed class, really? Well, it's a way for you, as the creator of a class, to say exactly which other classes are allowed to inherit from it. You get to create this closed, perfectly defined family of classes. And the best part? The Java compiler becomes your personal security guard, making sure no uninvited classes can sneak in.
And getting this set up is actually super simple. First, you just add the sealed keyword to your class declaration. Then use the permits keyword to give it a list of every single class that has your permission to extend it. That's it. Really, it's that easy.
Now here's where it gets really interesting. Once you've allowed a class to be a subclass, that new class has to follow a very specific set of rules. It has to make a choice about its own future. And this is a big one. Any class that extends a sealed class must be declared as one of 3 things. It has to be either final, sealed, or non-sealed. It's not optional. You have to pick one. So let's break down what each of those means.
Okay, the first choice is final. This is the most straightforward. When you mark your permitted subclass as final, you're basically saying this branch of the family tree stops right here. No other class can extend this one. It's a dead end, and that's exactly what you want sometimes.
Your second option is to just continue the pattern. You can mark the subclass as sealed itself. And if you do that, you're saying the controlled inheritance is going to keep going. That class then has to provide its own permits list, defining the next level of approved subclasses. And the third option, non-sealed, is kind of your escape hatch. It basically says, okay, the controlled inheritance thing stops with me. From this point forward, we're back to the old way, where anyone and everyone can extend this class. This is super useful if you want to let other developers, maybe using your library, extend your class freely. Okay, that's enough theory. Let's look at a real code example to see how this all fits together. This should make those 3 rules we just went over totally clear.
Let's imagine we're building a payment system. We can create a sealed class called payment. Now, by adding that permits clause, we're telling the Java compiler that the only valid types of payment in our entire system are credit card, PayPal, and crypto. That's it. No other payment types are allowed, period.
So let's look at what those children classes have to do. Our credit card class is final. That means you can't come along later and make a Visa credit card that extends it. The line stops there. But then look at PayPal. It's non-sealed. That opens the door for other developers to maybe create their own specialized PayPal payment types down the road. See? Both are totally valid because they followed one of the 3 rules.
So what happens if a developer on your team tries to add a new payment type, maybe bank transfer, that wasn't on our original permits list? You know, they write the class, they try to extend payment,
and bam, this is the magic right here. They don't have to wait for the program to crash or for a test to fail. The compiler stops them dead in their tracks with an error. This is so powerful because we're not finding bugs late in the game, we are preventing them from ever being written in the first place, all thanks to our sealed hierarchy.
Now, this powerful idea of sealing things off isn't just for classes.
you can actually apply the very same principles to interfaces, which gives you even more fine-grained control over your designs. Yup, you heard that right. You can use the exact same sealed and permits keywords on an interface. This lets you control precisely which classes are allowed to implement your interface, or even which other interfaces are allowed to extend it. There is one really important difference you've got to remember, though. With sealed interfaces, the permitted types can be sealed or non-sealed, but they can never be final. And that makes perfect sense if you think about it, right? You can't make an interface final because its whole purpose is to be implemented. So for sealed interfaces, you've got 2 choices for the children, not 3. Okay, so we've covered the what and the how. Now let's talk about the big one, the why. Why is this feature more than just some neat syntax? Why should you actually start using this in your projects? So why does all this matter? Well, sealed classes give you a new superpower for your designs. You can build way more robust and maintainable code because you are explicitly defining the entire universe of possible subtypes. This doesn't just help the compiler catch errors for you, it also makes your code so much easier for other humans to understand. You're literally baking your design decisions right into the code itself. So the next time you're designing a class hierarchy, just ask yourself, is this really meant to be open to the whole world, or do I have a specific, limited set of children in mind? If it's the second one, reach for sealed classes. Let the compiler be your partner in building safer, more intentional software. Thanks for tuning in.